Udah bisa.
Udah ya? Oke. Selamat siang, Sobat Atma semua. Selamat datang di seri ketiga dari rangkaian event dari Teknik Industri Unika Atma Jaya untuk webinar series. Ya. Supaya kita tetap dapat berkarya dan mempertahankan produktivitas walaupun kita sekarang lagi di masa COVID pandemi ini. Maka selama bulan Juni dan Juli ini, Teknik Industri Unika Atma Jaya mengadakan serangkaian acara webinar mengenai berbagai keilmuan yang berhubungan dengan teknik industri. Saya lihat dari daftar partisipan di sini cukup bervariasi, mulai dari SMA, kemudian ada mahasiswa, ada graduate, S2, S1, S2, S3, ada di sini. Jadi partisipannya cukup bervariasi. Saya harap kita semua nanti dapat sharing informasi dan pengetahuan yang berguna bagi para partisipan di sini dari semua kalangan. Oke, sebelum kita memulai webinar ini, host sudah memastikan untuk memute semua partisipan supaya nanti suaranya tidak distract ya. Oke, terima kasih. Kemudian topik webinar kali ini The Way to Smart Manufacturing. Ini topik yang sangat menarik. Kita akan berbincang mengenai apa sih itu smart manufacturing dan bagaimana aplikasinya nanti di dunia industri. Topik ini nanti akan dibawakan oleh Profesor Huang, Ph.D, Associate Professor dari Department of Industrial and System Engineering, Huang Christian University, Taiwan. Welcome, Professor.
Hello, everyone.
Hello, thank you for joining us in this event. Oke, sebelum Profesor nanti masuk ke dalam topik utama, kita mempunyai Atma Jaya, Teknik Industri Unika Atma Jaya mempunyai kerjasama dengan Huang Christian University Taiwan, atau saya singkat biar mempermudah CYCU Taiwan, yaitu dalam bentuk kerjasama 3+1+1, 3+1+1. Nanti ini juga akan dibawakan oleh kita akan dijelaskan oleh Kaprodi dari Teknik Industri, Pak Felix. Oh ya, sebelum kita masuk ke acara, saya akan men-sharingkan rundown, kira-kira introduction, welcoming introduction, sekitar 15 menit, 15 menit. Kemudian paparan presentasi dari Profesor Huang, about 40 till 45 minutes. Then we can continue it with question and answer, ya, Q&A untuk sekitar 20 sampai 30 menit, 20 till 30 minutes. Then it's closing session. Oke, saya sendiri, sebagai moderator untuk rangkaian acara ini, yaitu saya Vivi Trianti. Saya merupakan pengajar di Teknik Industri Unika Atma Jaya dengan spesialis di Work Product and System Design and Analysis. Oke, untuk memulai acara ini, saya perkenalkan pada Bapak Felix Prasetya Surbakti, STMT, Ph.D. Beliau baru saja lulus dari the University of Queensland di Australia dengan expertise-nya di Big Data, Business Process, and Quality Management. Untuk menjelaskan sedikit mengenai program di teknik industri dan di program 3+1+1, saya persilahkan Pak Felix untuk mempresentasikan. Silahkan Pak, berbagi info.
Ya,
Pak
terima
Felix,
kasih
silahkan.
Bu Vivi. Ya, terima kasih Bu Vivi. Good afternoon, Professor Barney.
Good afternoon.
I will explain some slides here about industrial engineering department in Indonesia, if you don't mind.
Okay, sure.
Right.
Go ahead.
Okay. Thank you. Baik, Ibu Bapak sekalian, adik-adik sekalian, saya lihat ada 88 partisipan saat ini dan biasanya akan bertambah terus. Jadi ini adalah webinar ketiga dari rangkaian webinar teknik industri yang rencananya akan diselenggarakan nanti 8 sampai 10 kali. Ya, di sini saya akan mencoba memperkenalkan ke Bapak, Ibu, dan adik-adik sekalian mengenai tentang teknik industri. Ya, teknik industri ini di Atmaja sudah lama sebenarnya, sudah 21 tahun, sejak 1999, dan kami pertama di Semanggi, kemudian pindah ke kampus Atmaja yang terbaru di BSD. Next. Nah, ini adalah kelompok keahlian yang ada di teknik industri. Ada 4 kelompok keahlian, ada ergonomics, ada rekayasa sistem manufaktur, kemudian ada sistem industri dan teknoekonomi, di dalamnya juga ada optimasi industri, kemudian ada sistem manajemen dan informasi. Next, itu adalah 4 keahlian utama di teknik industri yang mendukung industri 4.0. Nah, teknik industri, prodi teknik industri dilengkapi oleh fasilitas 5 laboratorium, ya. 5 laboratorium ini 5 laboratorium umum yang ada dimiliki oleh teknik industri yang lain, dan laboratorium terbaru adalah laboratorium Innovation System Laboratory, jadi laboratorium sistem inovasi. Next, apa aja yang dipelajari di lab? Ya, jadi lab-lab kami ini dilengkapi dengan peralatan-peralatan dan aplikasi yang state of the art, ya, yang paling mengikuti perkembangan zaman. Ada eye tracking, ada car atau mobile simulations, ada juga motor simulations. Kami juga dilengkapi dengan 3D printing di lab sistem inovasi, dan ada, kita lihat tuh ada juga virtual reality, ya, untuk mendukung lab mahasiswa di kampus. Untuk aplikasi, setiap lulusan teknik industri akan mendapatkan sertifikat SAP, ERP, ya, SAP di bidang ERP yang general, Enterprise Resource Planning, di mana lulusan-lulusan kami juga ada yang bekerja sebagai SAP konsultan. Jadi memang bermanfaat, ya, sertifikat ini di dunia kerja. Next.
Next.
Oke. Ini adalah kegiatan yang ada di teknik industri, ya, kegiatan lab, kegiatan mahasiswa. Jadi kegiatan mahasiswa di Atmaja itu sangat banyak sekali. 20-30 unit kegiatan mahasiswa ada, mulai dari ilmiah, olahraga, seni, budaya, keagamaan, macam-macam, komplit sekali. Kemudian juga ada himpunan, tentu saja himpunan teknik industri. Di situ juga mewadahi banyak kegiatan-kegiatan, diantaranya secara rutin kami setiap tahun mahasiswa menyelenggarakan kompetisi matematika, fisika untuk anak SMU. Student-student juga dilibatkan di event-event kompetisi tingkat nasional, sebagian juga ada yang juara. Di paling bawah bisa dilihat gambar dari kampus ketiga yang di BSD, ya. Kampus pertama di Semanggi, kedua di Fluid, ketiga di BSD. Sejak tahun 2017 bisa dilihat masih baru. Dilengkapi dengan olahraga, lapangan olahraga sepak bola, futsal, dan lain-lain. Dan ada juga dormitory. Jadi untuk mahasiswa dari luar daerah jangan khawatir, ada dormitory dengan harga terjangkau, dan tentu saja lokasinya yang di kampus, jadi sangat dekat sekali, bisa jalan ke kampus. Next.
Oke.
Next.
Oke, ini adalah kita tahu, Bapak Ibu, adik-adik sekalian mungkin belum tahu, ya, kalau orang di perkuliahan itu di kampus itu ada 3, kita sebut 3 pilar, ya, atau tridharma perguruan tinggi: penelitian, pengabdian, dan pengajaran kuliah. Nah, ini salah satu community service atau pengabdian masyarakat yang dilakukan oleh Prodi Teknik Industri Atmajaya. Jadi Prodi Teknik Industri Atmajaya dan yang kedua di Sampora. Yang di Ponggang ini sudah berlangsung sejak 2011, Ibu Bapak sekalian, adik-adik sekalian. Dan yang luar biasanya juga terakhir sudah bekerja sama dengan NUS Singapura ya, Nanyang University of Singapore. Jadi sudah bekerja sama dengan universitas bagus dari Singapura. Kemudian yang kedua adalah masyarakat di Sampora bekerja sama dengan BTPN Syariah dan mitra-mitra lain. Itu proyeknya adalah tentang urban farming dan pengembangan usaha ternak lele bagi penduduk di sekitar Atmajaya. Oke, kurang lebih itu kegiatan utamanya untuk mengabdi masyarakat. Nah, ini yang mau saya sampaikan khususnya kepada adik-adik SMA sekalian, ataupun mahasiswa juga yang lagi berkuliah saat ini. Jadi, nanti kita ada program, sekarang ada program bekerja sama dengan NYCU, jadi pembicaranya Profesor dari NYCU ya, salah satu universitas swasta terbaik di Taiwan. Kita ada program namanya program Student Exchange dan Fast Track ya, Fast Track. Program 3+1+1. Itu jadi programnya apa? Jadi programnya dalam 5 tahun, Anda bisa mendapatkan gelar S1 dari Atmajaya dan Master dari NYCU. Seperti apa programnya kita bisa lihat di slide selanjutnya untuk detail programnya. Next. Nah, ini info sekilas tentang, nah nanti itu bisa dijelaskan sebenarnya. Jadi sengaja nih di-skip oleh moderator. Nanti Profesor Benny juga akan menjelaskan lebih detail lagi tentang universitas beliau. Jadi kita langsung aja masuk program seperti apa 3+1+1. Jadi 3 tahun nanti kalian berkuliah di Atmajaya, di Teknik Industri Atmajaya, menyelesaikan 131 SKS. Bisa kita lihat itu ya di bagian requirement. Kemudian ada minimum GPA 2.75 ya, 2,75, minimum TOEFL 500, atau kalau 61 kalau internet based IELTS 5,5. Ini menurut saya sih cukup bisa digapai ya Ibu Bapak. Biasanya kalau di luar negeri itu 6 ke atas sekarang untuk IELTS dan 550 untuk TOEFL. Jadi harusnya bisa, tidak terlalu sulit. Nah, jadi 3 tahun belajar di Teknik Industri Atmajaya, kemudian di tahun yang keempat atau 1 tahun di tahun yang keempat, 1 semester di UAJ, 13 sampai 20 SKS, kemudian 1 semester lagi di CYCU, kemudian setelah itu tahun yang kedua adik-adik sekalian berangkat ke Taiwan dan berkuliah di CYCU selama 1 tahun atau 16 SKS. Next. Nah, saya akan berbicara sedikit tentang biaya. Seperti apa sih biayanya? Nah, biayanya seperti ini, adik-adik sekalian, khususnya adik-adik sekalian. Itu 3 tahun pertama tentu saja bayar biayanya seperti biaya kuliah di Atmajaya ya. Atmajaya sekarang kisaran per semesternya 20 juta. Nah, di tahun yang kedua, 3+1, jadi 1 yang tahun keempat atau 1 yang pertama, itu walaupun kuliahnya 1 semester di Atmajaya, 1 semester di CYCU, uang kuliah tetap uang kuliah yang di Atmajaya yang dibayarkan. Nah, itu nilai plusnya. Tapi nanti di tahun keempat, ketika berangkat ketika 1 tahun belajar di Taiwan, nah, jadi kalian itu bayar uang kuliahnya sesuai dengan uang kuliah di CYCU. Dan biaya hidup dan lain-lain juga tentu saja kalian yang bayar sendiri. Tapi ada ini, kalau adik-adik sekalian baca, ada ketentuannya. Kalau kalian memang berprestasi, nanti jadi ini person to person ya, tergantung dinilai individual, bisa mendapatkan beasiswa juga nanti dari CYCU untuk yang berprestasi. Jadi kurang lebih seperti itu programnya. Jika ada yang belum jelas, silakan hubungi kami atau tulis di chat. Nanti kami akan berusaha menjawab. Ya, terima kasih.
Oke, terima kasih Pak Felix atas paparan program ini yang sangat menarik. 5 tahun sudah jadi MSc, Pak ya? Wow, cepat sekali. Mungkin kita harapkan bahwa adik-adik bisa menangkap kesempatan yang sangat istimewa ini. Kemudian jika nanti ada yang tertarik untuk program ini, ada kontak Pak Felix di bawah ini, baik di email maupun di HP, bisa ke Pak Felix atau nanti secara umum bisa ke Atmajaya juga, ke website di Atmajaya. Terima kasih Pak Felix. Saat ini kita akan memasuki acara utama kita, yaitu The Way to Smart Manufacturing. Topik ini sangat menarik karena ini berkaitan erat dengan industri 4.0. Mungkin sebagian besar di sini pasti sudah mengenal namanya atau pernah mendengar istilah industri 4.0. Itu salah satu jargon yang sangat erat kaitannya dengan perkembangan industri, di mana dalam industri 4.0 terutama mengutamakan integrasi antara infrastruktur dan internet, teknologi informasi, supaya kita bisa melihat maupun mengendalikan proses. Nah, di TI Atmajaya sendiri, kita mempunyai banyak tenaga pengajar, kemudian lab tadi yang sudah diceritakan oleh Pak Felix, untuk bisa menjadi smart factory yang bisa menghasilkan lulusan yang akan siap untuk menghadapi era industri 4.0 tadi. Oke, kita akan memasuki acara utama kita, yaitu paparan mengenai smart manufacturing. Sebelumnya, perkenankan saya untuk memperkenalkan Profesor Huang. Halo, Profesor. Nice to meet you again in this online room. Hopefully you're always fine and safe, especially in this pandemic season. Okay. Oh, sorry, I have to unmute first the professor. Okay. Wait. Okay, for the host, can you unmute, Professor?
How about this?
Okay.
Okay.
Perfect. Perfect. Okay.
Good.
Good. Okay. Wait. Professor Huang is the associate professor from Department of Industrial and System Engineering, and currently he is a Vice Dean of International Office in CYCU. For the education, he's a Ph.D. in Industrial Education and Technology from Iowa University, US, and then with the expertise in application of neural network and physiologic, lean manufacturing, design for manufacturability, quality assurance, automated manufacturing process. Wow, a lot of expertise. Okay. Okay, he is trusted to teach the course about CAD and virtual reality, computer integrated manufacturing, lean production, quality control, and so on. Okay. Professor, I will give the presentation to Mr. Ferdian because I have to stop this. Okay, stop share, and then Mr. Ferdian, are you ready to share the screen? Okay, I stop first. Okay.
Okay.
Okay. Please, Mr. Ferdian, and then Professor, please present the presentation for about 40 minutes. Thank you.
Okay. Hello, everyone, all the professor and the student from Atmajaya and Indonesia. Is this the first slide? Can we return to the first slide?
Sorry, everyone is mute. Everyone is mute, Professor.
Yeah, this is not the first slide. Can we return to the beginning of the slide? Okay, good,
yes,
good.
Okay.
Yeah, all right. We will start from here. Okay, so it's good to have a chance to talk to all of you. Today I was told the audience is from very diversity, from like a high school student, undergraduate student, graduate student, and even the professor is all as the participant. So I will try to make my presentation as general as possible, so it can be fit everyone to understand what is the smart manufacturing. Okay, so I will start. This one we're talking about. You will see there is always a better way. You know, this is the slogan of the Department of Industrial and System Engineering in ISU. That's in CYCU. That's my department in here. So as an industrial engineer, or even as an engineer, from a very long time until now, we are always looking for a better way. We keep improving our daily life, our products, everything. So we put this as a slogan to encourage our students in the future when they get into their job, no matter what kind of trouble they face, they always have to think about there's always a better way. The same as the change of our industry. Okay, that's next. So the Industrial Revolution, you can see from a very, very long time ago. We do have 1.0, 2.0, 3.0, and for now, that's a very popular term called 4.0 industry or Industrial 4.0, okay, for this term. And how come the revolution will come from different era with a different term? It's just like what I mentioned earlier. We are always looking for a better way. Right, so if I use an example, okay, I use an example. For example, I think the coffee is very popular. It's very famous in Indonesia, right? So normally when we do the coffee roasting, if you think about at the very beginning, a human being, we just use a simple pot and cook it to get our coffee bean, right? But when we get into Industrial 1.0, that means we start to use machine with the power, right? Steam machine with the power. And then get into Industrial 2.0, we think about a mass production. We want to make more and more, so we start to create a production line. Okay, it's not only the machine to roast the coffee, but also the machine to pack the coffee bean. Okay, the package, everything. And later on, we think about, we have to find a better one. Okay, we think about not only the quantity, but also the quality, right? We want to make a quality, a better quality products. So we get into Industry 3.0. At that time, the equipment, the facility that we use is get into automation, automatic. What does automation mean? Normally, you can think about it like this way. You get into a machine, you just simply press one button. Okay, let it start. Then the machine will help you to do everything. That's we so-called. That's the generation we get into Industry 3.0. And right now, okay, we get into Industrial 4.0. So once we got the automatic machine, so we're still thinking about how to get the machine better. And in this Industrial 4.0, we think about how to make the machine like a human being, like us. Okay, as a human being, when we face a problem, we can think, we can react, right? So we think about during the Industrial 4.0, in this generation, actually, we are talking about how to think about how to make the machine to become smarter. Once the equipment becomes smarter, and then all manufacturing system will become smarter. And even in the future, we do have a goal to make the overall process, even in the factory, you can think about in the area, you will see no one in there. It's just the machine. You will only diagnose with the equipment, with the machine. That is the goal of Industrial 4.0. We so-called the cyber physical, right? So in the Industrial 4.0, those are the things that you always see in your daily life, okay? Especially like IoT, Internet of Things. Right now, everything in your daily life, you are talking about Internet. Everything related to the Internet, all right? Every day you go to the convenience store, you purchase something, do you know the stuff that you purchase will become a big data through the IoT. They will become a big data, and they will know your behavior. Okay, so once as long as the data has been analyzed, next time when you go into the convenience store again, then the step they will tell you how to do it. Okay, they will tell you what's the products. So that's what we call the key factor of the Industrial 4.0. So use the Industrial 4.0, use those concepts into our manufacturing system, into the factory. Okay, and then we have to think about how to make our machine in the factory, in the plant to become smarter, to become better. So actually in Industrial 3.0, we already have those equipment in the industry, in the factory. You will know, I believe some of you already heard about those terms like CAD/CAM, computer aided design, computer aided manufacturing, or even computer aided engineering. The overall MRP system or the ERP system that try to integrate the system. So that is the one, okay, already became mature. Okay, it's already become mature for the industry. However, even though we have this kind of system to assist our manufacturing, to assist the factory, to assist the operator. However, sometimes during, especially in the factory, during the manufacturing processes, there are still some problem happens. Next, okay. Next one. Okay. So actually, for those equipment or even for those facility, those are more related to we so-called Industrial 3.0. Okay. So for those one, actually, I would say like we so-called one-way ticket. It's only you tell them what to do. All right, you can set up those automatic machine. You tell them what to do. However, when something happens, when something goes wrong, okay, the machine cannot respond. So sometimes I will ask you, not only in the factory, even in your daily life, okay, when you face a machine, face an equipment, you can ask, can the machine monitor the processes? Okay, when you turn on a machine, when you start to run, okay, if something wrong, does the machine know is there something wrong in there? Okay, that's the first question. Okay, the second question is, can the machine respond when something goes wrong? Okay, so you have, if you would like to get into the Industrial 4.0, you want to get into a smart manufacturing, for every equipment, for every facility, you have to ask yourself, all right, when you look at the machine, even you look at the computer, okay, you have to look at the computer, you can say, okay, is the computer monitor all processes? Okay, when I start to operate the computer, it goes too hot, will the computer tell me? All right, if something wrong, we're gonna be shut down, is the computer gonna tell me? All right, that's one. All right, the other one is, once the computer, if that goes wrong, for example, just like what I say, okay, if the computer, the CPU goes too hot, all right, what gonna do? Or will it turn on the fan? Something like this, all right? So this is the basics as a machine, as an equipment, as a manufacturing. If you want to get into the smart, we so-called the smart or intelligent manufacturing, you have to make sure the machine, the equipment can do that. So I define, okay, basically I define the smart manufacturing. Simply, you can say, okay, the machine, it can see something, okay? So you can see something, it can feel something. The machine can, for example, feel the temperature, feel the vibration, feel the noise, right? They can do something, they can feel something. They can know something different, okay? So they also, they can think, okay? They can make some decision when they feel something wrong, when they feel temperature is too high, okay? What will they do, okay? Or try to lower down the temperature to try to cool down, or try to turn off something to cool down. Those are some reaction we have to do, all right? And even we have to know, the machine need to know how to adjust, all right? So once they make a decision, so okay, tell you it's too high, okay, it's too hot, then how many degrees of temperature that I have to drop down, okay, the interaction. So in order to do this, in order to do all these three things, to see something, to feel something, to think, to adjust. So for the new equipment that we use for the smart manufacturing, we have to start to use some we so-called sensing technology, like a sensor. We have to put a sensor, all right? Just like your air condition, actually for everyone, your air condition do have a sensor to sense the temperature. So you can tell you the temperature. So the sensing technology, the sensor is just like our eyes, our ear, our noise, help us to feel something. And then we have to develop, the most difficult part is the decision-making model. We have to develop a proper algorithm, okay, to analyze the sensor, the signal we got from those sensors. Okay, so if the machine tell me right now, such as right now the temperature is like 40 degrees, for example, then I have to, the information, when I got this information, I have to have some algorithm to tell me how to do. Okay, so those are the information that we have to do, right, the algorithm. And actually, for now, so far, the most popular decision-making algorithm that we use is those artificial intelligence, those AI model, AI algorithms, okay, such as the we so-called neural network, artificial neural network, or fuzzy logic. A lot of things actually has been widely applied, okay, in the manufacturing to do the smart manufacturing. Okay, and this slide actually is tell you how the smart manufacturing do in the factory. Okay, how we apply those IoT, cloud computing, big data analysis, okay, to integrate all of this into the system. Okay, and the majority part, okay, right now that we focus in the smart manufacturing is the machining, especially in the machining in this area. Okay, how to make the machine become smarter, okay, so they can do something. So in order to do this, you can see we use the more sensor, okay, we implement the sensing technology, we put more sensor into the equipment, into different type of machine, okay, to detect different type of information, different type of message. So this is the basic concept of the smart manufacturing. All right, next. So as a sensing technology, then so the sensor, when we got from the, might be from the machining, the processes, you will kind a lot of different kind of sensor like this. Okay, those are the example of the sensor. You can see it. However, okay, this is the difficult part. All right, everyone will know. Okay, it will look like this, the sensor, the signal will look like this. However, how to analyze, how to see the difference between each patterns, that's the difficult part. Okay, that's the difficult part. So currently, so far for our technology that we already have a very good sensor that can help us to receive the information, the sensing technology. Okay, that's no problem. However, for this kind of sensor, for this kind of sensing technology, how to make it become useful, it's still a challenge, okay, for the Industry 4.0. So right now, we still have a lot of researchers, okay, working on this area, based on different sensor, collect different sensing technology, and use different signal to be applied in different area. For example, my specialty is in the smart manufacturing in quality. So I'm pretty focused on quality issue. So that means everything when we fabricate, when we make it, we will think about the quality. Just like, for example, the example that I mentioned earlier, the coffee bean. Okay, for the coffee bean, I would like to know, okay, what kind of, if the coffee bean is in the quality or not. So I have to look at the signal to see what kind of signal is good for it. All right, once we got that, the next stage we have to do is to make a proper decision. All right, if the temperature, like for the air condition, if the temperature is too high, then what will I do? All right, right now, if the temperature is higher than what I expect, what will I do? If it's higher, 1 degree higher than what I expected, what will I do? 5 degrees higher than what I expect, what will I do? So different situation, we need to have a different response. All right, that is we have to do for the decision-making model. So for all those input factors, those sensing technology, those sensors, we find a useful sensor and then put it into the decision-making models. Eventually, the decision-making model will set up an algorithm and tell us what is the result, what's gonna happen, what should I do, something like this. Okay, so this is what we always do. Okay, and if you do see the current smart machine that we have, actually because of the Industry 4.0, more and more those equipment company, when they develop their equipment, their machine, they try to make their machine to become smarter, to become they can do something, okay, to like replace our human operators. So far that we have, okay, the machine that we have, that we always see is like a healthy, smart machine healthy. Okay, that means the machine, they can do some their own diagnosis. They can know their status. Okay, so actually so far, I'll set up like an example, the vehicle, right? Currently, right now the vehicle getting smarter and smarter. The vehicle right now, they can tell you, okay, you have to change the oil, right? Or sometimes the vehicle, they will tell you, your tire, the pressure, tire pressure is a little bit low. All right, you have to feel, okay, something like this. Those are with so-called status diagnosis, okay? So right now for the smart machining, the status diagnosis has been actually, yes, it's been applied, has been used in the equipment. However, we still have a big issue. Still have to solve the quality issue. And that means so far right now, those machines still cannot tell you okay, once they start to do the fabrication to make the products, they still cannot tell you what is the quality of the products. They still cannot tell you this part, all right? So because of this, okay, because of this, so you will see we have to develop some quality inspection equipment, okay? So we will have one machine. Right now, the way that we use to solve the problem is we will have one machine to fabricate the products. We will have the other machine to inspect the quality, okay? That means you will take extra time to do this. So you will know, okay, the quality inspection I mentioned, the most time consuming one is the offline. All right, I fabricate a product and then I bring it into the quality lab, okay, to do all the inspection. Might be the dimension, the surface, roughness, something like that. The other one is easier, is we so-called online dimension. Okay, just on the production line, right after my fabrication, I will have a machine there to inspect, okay, to inspect, okay. Even though right now we use this way to try to make our manufacturing process become smarter. However, it's still not good enough. Okay, the quality issue is still there. I don't know. If you are the graduate student or undergraduate student, okay, probably I can ask you the question. Okay, do you think the quality inspection is necessary? All right, or do you think the quality inspection is valuable? Right, so this is a very, very big issue in here. We know we have to do the quality inspection. However, when we do the quality inspection, actually it is wasting time. It will reduce our productivity. Okay, I know some of you are already the student of industrial engineering. You should know this kind of concept. So the best way is we don't have to spend extra time to do the quality inspection. So how to do that? How to do that? That is the third one that I mentioned, the type of quality inspection. The third one is we so-called in-process quality inspection. Okay, in-process quality inspection, that means during the fabrication, during the machining processes, simultaneously, I can know the quality of the products. That is the most important one. So you don't have to spend extra time to do the inspection. So that's what we so-called in-process quality inspection. So this is the one we want to put it into the smart manufacturing. That means in the future, for every machine, okay, we will mount, we might mount a lot of sensors in there, and we might develop a lot of decision-making algorithm in there. Okay, so once the machine start to fabricate the material, at the same time, I will know exactly if the quality is good or bad. All right, so you don't have to bring the material, you don't have to bring the part to the other machine and to do another inspection. You don't have to do that. All right, so that's the goal. That's the goal we would like to do in our smart machining, in our smart manufacturing. Once we can successfully conduct the smart machining, then to achieve the smart manufacturing, well, will no longer a dream. Okay, it will be easier to do that. Okay, next. Next one. Okay, so for this part is more, so at the earlier part, the parts that I already mentioned to all of you, I just give you a big picture about what is smart manufacturing, okay? What is requirement for the smart manufacturing? Okay, for any one of you, if you do interested in Industrial 4.0, if you do are interested in the smart manufacturing, this might be a direction, maybe this might be something you can think about for your future career, or for there's something for you to prepare for your future study. And the following part, I was just mention it quickly because it's more related to my own research. Okay, so this is the one we so-called in-process surface roughness prediction and system. So actually, this is a system we use to monitor the quality of surface roughness. Okay, you can see this. So we have two systems. Okay, on the upper right side, that is a surface roughness prediction system. So we will predict the surface roughness. That means we will monitor the quality first. Okay, and then in the middle of button, okay, that is the one that means once if you find once the quality is not good, okay, it's out of control, then how can we adjust the machine? Okay, how can we adjust the machining parameters? Then we can continue to fabricate a part that can be within control. So we do have two systems. One is this one. Okay, the other one is NN-based adaptive machining parameter control system. So both systems we have to use. So we will try to make the machine to become smarter. Okay, next. Okay, this is the same algorithm to show. Next. All right, then this is the other research that I use. It's focused on what so-called self-learning. So I use this to detect the quality of cutting tool. Okay, if you are interested, you can look at the paper. All right, but this paper we focus on what so-called self-learning. That means we will let the machine. It's not only have the decision-making model. It's not only know how to adjust the machine, the status. However, we also want the machine has the ability to learn. Okay, everybody, we have to know the machine, every equipment that will getting older and older. All right, the new machine, the condition of the new machine is quite different with the condition of the old machine. Okay, so when the machine getting old, some of the condition is changed, we also expect that the machine has the ability to learn by itself, so they can also can adjust some of the parameters by itself. So that's the key point that I put in this paper. Next. All right, those are the flow chart of how we do. So this is the one, we do it right in here, self-learning. So once we detect the tool, and if the situation is not right, they can come back to change, okay, to change the algorithm. All right, so sometimes, right, even though we develop an algorithm, and if we find the prediction value is not the same as the real one, we have to tell the machine, you have to learn again, because that you learned earlier is not right. Okay, that's what we did. Next. All right, so these are the signal information. I just show you. Okay, some of what's the difference. So you can, on the right side and on the left side, you can see the difference. So those are the one. In the future, you might see many different type of signals. However, you have to know how to tell the difference. Next. Well, okay, those are the self-learning. This just show you some of the results. You can see at the very beginning, okay, 96%, and he start to learn. So the accuracy is getting better and better. Eventually, it can reach 100% during the learning processes. Next. All right. Okay. How many time? So I think the time is probably is up. So the following is just some of my own research. It's all related to the smart manufacturing and the smart machining. And what they do is use all those concepts that I mentioned earlier. All right. The only difference might be I will use different algorithm. For example, this one I use the neural network as an algorithm to do the surface roughness monitoring. So those could be a very good research for the student to conduct. So if right now you are the undergraduate student in the Atmajaya, and if you are interested as the department chairs mentioned about 3+1+1, right? And if you are interested in this area, you can come to CYCU to find me, okay? These are, I just pass it very quick, okay? Just show you some of the results, all right, how I did, how I set up this. Okay, so the last one, okay, the last one, I just want to tell you the newest one, okay? This is the newest one of the smart manufacturing, okay? We so-called the online training. This is the one we so-called online training. So that means I will train the model in a very short period of time. Okay, this is a good for high variety products. Okay, especially if you do work in a factory, you will find let's always change the line. All right. So those are my lab. I just show you some of the facility that I have in my laboratory. Okay, can you see the hole? Actually, it's only 1 millimeter. It's a micro drilling for the prediction of the tool life. Okay, you can see all those are the facility that we use to conduct the do the smart machining. Okay, next. All right, so finally, I just simply say it again. If you want to do the smart manufacturing, well, you have to define a proper sensing technology, sensing signal. That's one. And then develop a proper decision-making model, such as neural network, gray, genetic algorithm. Okay, for all things can be a good decision-making model. And the third one is make sure it is adaptive. It can help your machine to change. That's the most important part. All right. So the above part is about the smart manufacturing, the way to smart manufacturing. I'll just give you a very brief introduction about how to conduct this. Okay. So should be okay. Next. All right. So I think next should be the one we will introduce. I will spend a couple minutes to give a student about the CYCU, Zhongyuan Christian University. If some of you are really interested in the 3+1+1, this kind of program, you complete your bachelor for the first 3 years will be in Atmajaya, and then in the 4th year you will come to CYCU as an exchange student. And then if everything goes well, then it is possible for you to just spend 1 more year to get the master degree in CYCU. Next. Next one. Okay, so Zhongyuan Christian University, okay, you can see the map. It's in the north of Taiwan. It's in Taoyuan City. Actually, it is very close to the airport. So once you arrive the international airport to the campus, it will only take 20 minutes to the campus. So the history of the university has been more than 60 years. Total right now we have 16,000 students, and around close to, right now it's close to 2,000 international students, degree or non-degree seeking in the campus. So actually when you come to CYCU, you will see a lot of international students. Right now we have 7 college, 1 school, and 29 departments. Okay, next. So this is some of the information of the CYCU. Actually, we are the #1 private university, comprehensive private university in Taiwan. And overall ranking, okay, you can see that always in top 1,000, and sometimes we're between 800 to 1,000. So it's still a very good university. For engineering, we have the accreditation. IET Engineering Education Accreditation is very similar as the Washington Accord. That means once you got a degree, it can be recognized, also be recognized in Indonesia, in your country. Next. All right, so you can see the population of the portion of the international student degree or non-degree seeking. Actually, Indonesia student right now, we have around 15%, okay? And now we're getting more and more students from Indonesia. Okay, most of the students from Indonesia, they do have very good performance. Okay, and here I will quickly show you some of the facility that we have. The library, okay, the top 2 is the library. The bottom 2 is the student learning center and the music center. Next. The picture. Oh, does it change? Okay, oh, okay, I got it. All right, sports center, the one you like, okay, especially for a gym, right? The gym that you like. A swimming pool is warm water. So you can swim there all years, okay, it's warm. And dormitory is normally a 4-bedroom, okay, 4-person per room. Next. Next, okay. So that is the one. I just give you a brief introduction about the CYCU. If you want to know more information, you can simply go to the website, type www.cycu.edu.tw. So you can get into our website. And this is about the Department of Industrial and Systems Engineering. So it's also, we do have a very good history. It's a very old IE department in Taiwan. So far, we have around 20, okay, 16 to 20 full-time faculty. Especially the most important is, I can say all of our faculty are graduate or they got either our master or PhD degree from overseas. And some of them from United States, and some of them from Europe, the country in Europe. So basically, it's not a problem for us to conduct the English lecture. It should be okay. Okay. So we have a big number of alumni. And our specialty actually is very similar, very much with the major area in Atmajaya universities. So you can see we also have the operation research, quality, information technology, ergonomics, okay, and like Industrial 4.0, computer programming fundamentals. So those programs are also the concentration in the ISE CYCU. So I would say once you got your degree in Atmajaya, when you come to CYCU, continue for your master degree will be very easy. Okay, you will always find the professor in the area that you want to study. And besides the master degree, okay, actually in our department, we also have the PhD degree. So if once you complete your master, if you are interested, you can keep going to pursue the PhD also in the CYCU. It should not be a problem. Okay, actually right now we already have some of your lecturer from Atmajaya right now in here to study for their PhD, and they did a very good job in here. All right, so this is the 3+1+1. I think yeah, the department chair already mentioned earlier, so I don't have to mention it again. Next. Okay.
Okay, Professor?
Yes.
Okay, is the presentation about the CYCU and then the topics already done, finished?
Mm-hmm.
Okay,
Yes. Mm-hmm.
thank you very much.
Thank you. Thank you for this opportunity.
Yes, I will explain recap again about the program. Okay, because there's a lot of question about the program. Okay, teman-teman semua, saya mau merecap sedikit mengenai program kerjasama akademik 3+1+1 ini. Jadi selama 5 tahun kita dapat kesempatan ya untuk mencapai Master of Science dalam 5 tahun. Jadi di sini program ini berlaku untuk mahasiswa aktif dari Teknik Industri Unika Atmajaya. Kemudian Pak Ferdian, next. Oke, jadi di tahun pertama, 3 tahun pertama itu mahasiswa menyelesaikan seperti biasa 131 SKS di Unika Atmajaya. Nah, kemudian keistimewaan ada di tahun kedua. Di tahap kedua, yaitu tahun keempat. Di tahun keempat, itu mahasiswa bisa menyelesaikan di CYCU untuk 16 SKS, tapi bisa dikonversi ke dalam SKS di Atmajaya. Jadi satu kali kerja gitu ya, sekali menempuh bisa mendapatkan SKS di CYCU maupun di Unika Atmajaya. Jadi di situ keistimewaannya. Dan di tahun kedua ini, di tahap kedua ini, yaitu 1 tahun pertama dari 3+1+1, 1 year yang pertama ini bebas biaya. Jadi tuition fee-nya free, ya, baik dari Atmajaya maupun CYCU. Lumayan itu, ada sekitar 20 SKS free untuk tahun keempat itu. Kemudian baru tahun kelima full di CYCU untuk mendapatkan gelar Master Science tadi. Nah, bagi mahasiswa atau calon mahasiswa yang tertarik, bisa nanti kita di diskusi ini untuk tanya jawab juga, nanti ada Pak Felix maupun Pak Ronald sebagai dekan kami yang akan bisa menjawab. Nah, sekarang kita sampai ke sesi tanya jawab. Pak Ferdian, saya ambil alih lagi share screen-nya mungkin? Atau
silakan Bu.
Oke. Ya, saya itu udah di off screen-nya? Udah. Oke, saya share. Maaf. Bentar ya. Oh. Okay. Now is the time for question and answer session. Okay. Oh, sorry. I have to close this first because the chat. It is on the chat. Sorry. Wait. Penanya pertama tadi dari, sebentar ya. Oh, maaf. Pak Ferdian, sorry Pak. Lebih baik Bapak lagi Pak yang share Pak. Saya nggak bisa lihat chatnya yang di sini. Maaf Pak. Oke, Bapak lagi yang share ya. Saya nih jawab yang chat. Oke, penanya pertama ada, oke, ini AM, from AM. AM, Bapak atau Ibu ini, tolong videonya dinyalakan. Bapak atau Ibu atau saudara, AM, saudara-saudari. bertanya mengenai implementation of the smart manufacturing for the production facility that has so many different kind of product design. So the facility has a variation of product type or product design. How the smart manufacturing system can be implemented in that kind of industry or facilitation? Okay, wait. Prof. Bernie masih ini ya, masih di mute. Bentar.
Okay.
Okay, Prof.
Okay. Good. Well, yes, exactly. Right. Especially we will not especially in the factory, we do have different machine, right? And especially for every machine, we have to fabricate different type of products, and we keep changing line. That's the real situation we face every day. So when we develop, that is the one I mentioned at my last slide. We're talking about the online training. Okay, online training. That means we traditional way that we use for smart manufacturing is we will use the big data. We will use the big data and try to collect a lot of data and train a model, a decision-making model. However, this kind of model, right? Sometimes once we change the products or once we change the material, it will be changed. Okay, the model could not be suitable. So in these 2 or 3 years, I use this online, we so-called online training method. Okay, so online training method, they do have a limitation. Like, okay, because I want to do the online training, so to train to get the decision-making model in a very short period of time. So the algorithm that I have must only can accept few data sets. Okay, those few data set probably is the data that I get from like change over time, the change over period. Okay, or the set during the setup time, right? When we want to change from one product to the other, normally we have to set up the machine, right? Okay, during the setup processes, I might collect some data, some information. With those limited data, can I build a decision-making model? If I can build it, then that is the one we call online training. So if you are interested in this area, actually, right now the decision-making algorithm that can be used for the online training are limited. You can, I give you a direction for you to study. Right now we can use a grade, we so-called grade prediction. Okay, that is the tool that we can use to develop the algorithm for the online training. So you can see this. Just during this is the one that we use for the setup. Okay, during the setup time, I will develop a model. Okay, I'm sorry, this is in Chinese. Once the product has been completed, then this model will be erased. And next time when I change to a new product, then I have to train the model again. This is we so-called online modeling, online training.
Okay.
Mm-hmm.
Yes. Okay, so the challenge is actually the key is in decision-making model, because the challenge, because of there are variation of product, so the decision model should be robust.
Should be changed.
Yeah, should be changed all the time based on the variation of product. Okay.
Exactly.
Saudara Arianto, masih ada yang mau ditanyakan lagi?
Sudah cukup, Bu. Terima kasih.
Oke, terima kasih. Saya lanjut ke penanya kedua. Oke, sebentar. Yaitu saudara atau Bapak Mikey. Oke, Mau ditanyakan langsung atau saya mewakili Bapak Mikey, Saudara Mikey? Oke, let me ask this on behalf of Mikey. Okay. I would like to ask, is there any challenge or limitation in developing smart manufacturing in 4.0? Yeah, challenge and limitation of the development of smart manufacturing.
Okay.
Yeah.
Actually, if you want to know right now, currently the biggest challenge is about I would say the data collection. Okay, we can collect some we so-called big data analysis. Actually, right now every day, okay, if we do if the company, the factory, they already make their became an automatic company, a factory. Well, they every day they might collect a lot of data. They might collect a lot of information. However, the issue is they don't know how to use those data. Okay, you will see every day in every company in their database there has a bunch of information in there. However, how to make those information become useful, and that's the challenge part. The second challenge is the one I mentioned about, like a sensing technology, right? If you would like to run for Industrial 4.0, the sensor in each equipment is very important, right? Without those sensors, it's not easy to control those machines. So for that there will be a lot of cost for the company, because if they want to, they might either change their equipment, become a new machine, or they have to manually to install those sensors into their machine. So both of them will cost them a lot. That's gonna be a big challenge for
Okay.
the
How about the
factory.
limitation, Professor?
The limitation for the smart manufacturing?
Mm-hmm.
I will say, actually, currently it's still those the information, the algorithm. Right, I would say the algorithm that we have, actually, even though right now we have many algorithms to try to do this. However, because just that, I think that's one of the students asked earlier, the situation keep changing.
Okay.
Right. However, we still cannot have an algorithm can 100% guarantee say, okay, the result is correct.
Okay.
So far,
Okay, so the main challenge are in data collection, because there's a lot of data, and how to transform it to certain information that we need.
Yes.
And also to give a proper sensor to get the data is the biggest challenge. And then for the limitation about the accuracy of data. So we can get the information that we want. Yes. Oke. Untuk Mikey tadi sudah jelas. Jadi kesulitannya, terutama challenge-nya adalah karena kita mempunyai data yang sangat banyak, data collection, dan bagaimana bisa mentransformnya menjadi informasi yang berguna untuk perusahaan tersebut, dan bagaimana mendetek ya data tersebut dalam sebuah sensor. Itu juga challenge tersendiri karena membutuhkan teknologi tertentu. Kemudian juga ada masalah lagi, limitation-nya di akurasi data. Bagaimana keakuratan data itu dapat dijaga supaya informasinya tidak salah. Gitu. Untuk Mikey, ada tanggapan lagi? Tidak ada? Oke, terima kasih. Kita ke pertanyaan selanjutnya untuk Bapak atau Saudara Boni Laks. Mau ditanyakan langsung? Atau saya? Oke, saya wakili. Oke, the question from Mr. Boni Laks. What is the best or appropriate of Okay, what is the best appropriate of facility layout for such the smart manufacturing system? Okay, so the optimal facility layout for smart manufacturing system.
The optimal layout?
Yeah, the best layout or optimal layout for the
It's a very good question, but so far I still don't have the answer.
Okay.
Really, yeah, how to make it become the optimal? Optimal is the one we still try to, we are still pursuing. Yeah, during for the last decade, I conduct many research in this area. I still cannot say it is the best. We always still can find some way to make it become better. So I cannot tell you the answer what is the optimal. I can only share with you the direction. Okay.
Okay.
Yeah. Once we get into all the research actually is from what really happened in the industry. We try to satisfy the need of the industry. So when you get into the industry, when you get into the company, you see their problem, then you try to find a way to help them to find a solution. Okay, so just what I did, just solve it one by one, and one day you will reach the close to the optima. Mm-hmm.
Okay. Maybe then. Okay, that's the continue of the question from Mr. Bonilax. Are there difference performance facility, the difference of performance between facility layout in classical manufacturing facility and then and the smart manufacturing? So the difference between the classical and the smart
layout?
Manufacturing, the layout, yes.
The layout, well, basically, you don't have to make a big change. It depends. Okay, it will depend. If your layout already in the level of Industrial 3.0, like basically all the facility that you have already automatic, then you don't have to make big change. It's gonna be easier for you to get in from 3.0 to 4.0. However, it's if the facility, the equipment that you have in the factory is only to Industrial 2.0, and then we have to change the layout to depends on how you might need to reorganize the equipment, the facility, all right, to make it become smarter. However, it still depends on what kind of product that you fabricate.
Okay.
Mm-hmm.
Okay. Then it depends on the status of the current facility layout.
Mm-hmm.
If it is already in Industry 3.0 fit to the Industry 3.0, then it will be easier.
Mm-hmm.
Then if the classical is still in Industry 2.0 and so on.
Yeah, they might take a longer time or the overall layout need to be rearranged.
Okay, okay. The Mr. Bonilax say it's not optimal layout, but appropriateness. Is the answer is the same or maybe different? If I say, oh, it's not what he means, not optimal layout, but appropriateness of layout. Is
Could
it
be.
The same?
Yeah. Right now we will say probably is a proper layout. Normally, yeah. Because when we're talking about Industrial 4.0, actually it's based on Industrial 3.0. And what's the difference? Something that actually you don't have to do the physical change.
Okay.
Like the internet, IoT, like the computer networking. Actually, you will see all those things are just somewhere. You probably when you get into the factory, you won't see it. Yeah, you won't see it. That's the new trend of the Industrial 4.0. Mm-hmm.
Oh, Okay, so it needs infrastructure like internet and so on. So it will affect the layout. Of course, it will affect the layout. So the layout has to proper with the new technology, the internet technology, and so on.
Yeah. I'll
Okay.
say that.
I will go to next question from Andi Kurniawan from mechanical student. Okay, it's quite detailed, the question. Mr. Andi Kurniawan, will you ask it yourself? Mr. Andi Kurniawan? No? Okay. I will ask this for you on behalf of Mr. Andi Kurniawan. Is a mechanical student. It's about compensation module of error detection with integrated to CAX system such as CAD/CAM and self-learning machine with integrated like sensing and decision making. Then I would ask if I interested to do research in CYCU about smart manufacturing, what research that perhaps could be done in CYCU?
Okay.
Yeah, because he is also interested in 3+1+1 program.
Okay.
So what kind of research that maybe fit to his interest?
Okay. If you would like to focus on in the mechanical engineering, am I right? Is he a student of mechanical engineering?
Mechanical engineering, yes.
Yes, in mechanical engineering, I know we do have some professor focus on the molding. Okay, it's just like how to create a better mold in smart manufacturing, molding. For me, in IE department, in my department, I would say what I did is I focus on the CNC machine. Excuse me. The CNC machine, I will do the machine tool detection and the machining quality. Those are two things that I focus on the research right now. So if the student you are interested in this area, these two areas, the cutting tool quality and the material quality for smart manufacturing, for smart machining, you are welcome to the department.
Okay. So your suggestion for the topics are about cutting tool quality or material quality for smart manufacturing.
Yes.
Yes. Okay, Mr. Andi Kurniawan. Is it okay? Still have any question? Okay. Okay, if it is not, I go to next question from Mr. Iwan Junaidi. Okay, Mr. Iwan, do you want to ask it yourself?
Yeah, hello.
Yeah, okay.
Hi,
Iwan?
Professor. I have questions because smart manufacturing is very wide. For example, can detect the tooling failures or
exactly
predictive maintenance, agile production lines, supply chain. So from what we have now, the technology and then the human resources, what would be the easiest way to implement to start first? Yeah.
What will be the easiest way?
Yes, correct. To implement the smart manufacturing.
Okay. Good question, but not easy to answer. Well, I would say, well, you can, if you would like to make the research more related to the practical, probably I would suggest you to observe what's the current situation of industry in Indonesia. So you can base on the current situation to develop it. Okay. So I would say my experience, the reason that I select the CNC to develop is because my working experience before is pretty much focused on the CNC machining. So I do know the limitation, the situation or the problem of the CNC. So when I want to make it become smarter, it's easier for me to find how to make it smarter. So for the smart manufacturing, yes, they do have so many different ways. CNC machine is just one of it. Okay, if you come to Taiwan, okay, the most popular industry in here is semiconductor. So actually we do have another group of researchers. They focus on their research on those equipment in the semiconductor the facility. So it depends. I would say it depends on what might be more related to your future career. That would be a good one for you to study. I don't know if that answers your questions.
Iwan, Mr. Okay, I will unmute Iwan. Okay, wait. Oh, Mr. Iwan, is it?
Oh, yeah. Hello. Yes,
Hello.
yes, Professor. Thank you for your reply. Yes, understand.
Okay, okay.
So it's based on the requirement and the condition of the current
I would say it's better to base on what they need. Yeah, it's gonna be easier. So you can, when whatever the study that you in your research, your study can really contribute to the society. It will be better.
Okay.
Mm-hmm.
Okay, I think the list of question is finished. Is there still any question from the participants here? Please raise your hand. Okay. Host, please help to see if there is someone raise the hand. Okay. No? Okay. I think all the questions have been answered by Professor. Okay. Okay. Since it is already almost 2:30, I think.
Oh, okay.
Yeah. There's so many questions. Thank you that you already given us your expertise, your experience about the smart manufacturing. Hopefully, it will be useful for all participants here.
Okay.
Okay. And we hope we can meet again, Professor.
Sure,
event and collaboration.
Yes, of course.
Okay, thank you, Professor. Then we can go to the next. Okay, please, Pak Ferdian. Nextnya apa? Habis time for habis Q&A. Setelah Q&A. Setelah Q&A yang tadi. Oke. Pak Ferdian? Atau saya mau ini? Saya yang share. Oke. Oke, saya share. Which? Oke, screen-nya terlihat? Screen-nya sudah terlihat semua?
Oke, Bu.
Sudah? Oke? Ya. Oke, saya akan memberikan sedikit konklusi mengenai topik kita hari ini. Jadi, smart manufacturing, kalau kita lihat sebenarnya tidak fully integrated dan collaborative manufacturing system yang bisa merespon secara real time perubahan-perubahan yang ada dalam kondisi di sistem kita, ya. Dalam hal ini misalnya factory. Jadi, smart manufacturing itu kebutuhan utama jika kita mau memasuki industri 4.0. Nah, fungsinya smart manufacturing bisa untuk sense any changing tadi dengan sensor untuk menangkap data, kemudian dengan berbagai model decision making bisa digunakan untuk mengambil keputusan dan juga bisa digunakan untuk mengaktualisasi keputusan menjadi suatu physical action. Dan aplikasinya sebenarnya bisa tidak harus online, bisa offline, bisa online, tapi dengan berbagai benefit dan limitation dari masing-masing cara, baik offline maupun online. Oke? Nah, setelah sesi utama ini, saya mau menginfokan mengenai next event kita, yaitu webinar untuk yang seri keempat, yaitu mengenai product development. Ini nanti kita ada tanggal 26 Juni, June 26. We have session about product development, jam 2 sampai 4 waktu Indonesia Barat. Kita akan berdiskusi dengan Director of Design Operation dari Gojek. Nah, jadi kita akan berdiskusi mengenai Lean UX, product development, terutama menggunakan Lean UX di Gojek. Jika tertarik, bisa langsung mendaftarkan di link yang tersedia, maupun bisa scan langsung di poster di sini, ya, QR code-nya. Oke, kemudian tentang evaluation form dan sertifikat, host bisa tolong membagikan juga di sini di chat room-nya untuk evaluation form di tinyurl.com evalwebti3. Nanti diharapkan partisipan bisa mengisi evaluation form ini dan bisa setelah disubmit nanti kita akan mengirimkan e-certificate ke alamat email yang bersangkutan yang telah didaftarkan sebelumnya. Oke, sudah ada di chat room ya, host? Untuk tinyurl.com evalwebti3. Oke. Sudah, oke, sip. Nah, sekarang last but not least. Ini yang terpenting. Photo session.
Photo section.
Ayo masing-masing kameranya dibuka. Saya off ini dulu ya. Off share screen. Oke. Photo session, kameranya, videonya mohon dibuka semua. Ini mungkin ada 5 page ini. Ada 5 page, jadi nanti ini agak lama. Tolong Pak Marcel bisa memandu fotonya. Ini belum semua kebuka ini.
Oke. Page 1 dulu ya, senyum ya. Oke, cheese. Oke, page 1. Tahan dulu ya. Tahan dulu.
Sebentar Pak, masih ada yang belum kebuka videonya.
Okay.
Videonya kita tunggu kebuka dulu. Ya, dibuka dulu videonya, mungkin ada lag sinyal untuk membuka video. Sudah semua?
Iya. Oke. Bentar Bu. Oke, tahan ya. Oke, 1 udah ya. Oke, next ya. Oke, tahan dulu teman-teman, tahan dulu. Wih, banyak yang nggak kebuka. Oke, tunggu, kita buka dulu.
Kita nggak tahu ya ada di page keberapa ya, jadi selalu tersenyum.
Senyumlah untuk 1 menit ke depan. Sampai kering. Oke, saya coba ini, nggak apa-apa, nanti beberapa kali. Oke, saya cek. Oke, tahan dulu. Tahan dulu, next yang ketiga. Next yang ketiga. Oh, masih kosong. Ini kosong semua nih. Ini, oke. Kosong semua nih. Nggak apa-apa deh, biarin deh.
Nggak apa-apa, itu namanya kan ada.
Itu,
tapi...
iya namanya ada. Oke. Tahan dikit ya, tahan dikit. Oke. Tahan dikit. Maaf ya, lama dikit ya.
Oke,
ada 5 pages. Udah, Bu. Ya, thank you.
Ya, terima kasih teman-teman. Untuk partisipasinya, jika ada pertanyaan lebih lanjut, bisa Japri tadi di email maupun di nomor tentang topik ataupun tentang program 3+1+1. And thank you, Professor, for your time and your invaluable knowledge for us.
Thank you.
Okay. See you in next event, and next time maybe we can meet, not online maybe.
Yeah, maybe in
Hopefully
Taiwan or
not online.
Indonesia.
Yeah, we can.
Okay.
Yeah, we can meet physically in Taiwan or in Indonesia. Okay?
Yes, yes.
Oke,
Okay.
teman-teman semua, jangan lupa ya join ke next event di 26 Juni. Bisa daftar mulai sekarang, juga bisa daftar di ini yang tersedia.
Dia sebenarnya belum.
Aduh, maaf, ada ini. Oke. Ada yang mau disampaikan, host? Atau sudah? Tidak ada? Oke, kalau gitu terima kasih semua teman-teman. Saya ucapkan selamat berpisah. Sampai ketemu lagi. Terima kasih semuanya. Nanti untuk sertifikat akan dikirimkan segera. Saya mohon isi evaluasinya yang ada di link tiny URL, ada di chat itu. Nanti habis itu setelah disubmit kita akan kirimkan sertifikatnya. Kemudian video ini semua akan diupload di YouTube. Nanti akan dikabari linknya di YouTube. Untuk PPT-nya nanti akan kita tanyakan dulu ke Profesor, dikoordinasikan dengan Profesor, boleh di-share atau tidak. Oke, terima kasih teman-teman. Sampai jumpa di next event. Webinar seri 4 nanti. Terima kasih. Bye-bye.
Bye.
Bye.
Bye. Thank you, Prof.
Thank you, Prof.
Thank you.
Thank you, everybody.
Thank you, everyone.
Bye.
Thank
See you.
you.
Thanks everyone.
Thank you.
Thank you. Thank you. Oh, you're welcome. Okay, so I have to just take deep. Yes. Okay.
Pak Fer, recordingnya ini. Pak Fer, recordingnya udah di ini belum?
Di stop
Udah
aja.
ya? Gua stop
Stop.
ya. Ya, gua stop ya.